right? And all right, so I'll be back to check for people that come late. I'll be back around the 15-minute mark to check for those people. No real announcements other than, this is the end of week 10. So that means that week 12, we can anticipate exam 3 over chapter 2. And otherwise, we're just going to go ahead and hop into the material for today. As questions as we can. It says, consider this polynomial, write the degree, the leading term, yada, yada, yada. So the degree of this polynomial is going to be the highest power on any variable. In this case, it's going to be 5. And then it says the leading term. So that's going to be the term with the highest variable. So that's going to be 2x. Let's go here. 2x to the power of 5. Okay. And if anything is not clear, feel free to unmute yourself to get my attention and we can talk about it. The leading coefficient is 2. Okay. And the constant term is a term without a variable. That's going to be -6. So with this one, the degree is the highest variable, the power on the highest variable, which is going to be 7. The power of the highest variable. The variable with the highest power. That's what I was trying to say. I was like, why does it keep sounding so weird? The variable with the highest power. The leading term is going to be the term with the highest power. So at first glance, you might think that it's 5x to the power of 7, but we need to account for that denominator of 7, right? So because we're dividing by one term, you can actually distribute that across the top. So that's instead of 5x to the 7 is 5 over 7, 5/7. X to the power of 7. Okay. And again, I'll check Zoom again in about 12 minutes. The leading coefficient is 5 over 7. Okay. The degree of this polynomial, the highest power is power 5. Okay. Let's see, leading term is pi over 2 x to the 5th, pi over 2 x to the power of 5. Let's see, yeah, I didn't hit my 2 for some reason. The leading coefficient is pi over 2. Okay. So I think we said when we were when we talked about this, a property of polynomials is that the graph is a smooth, continuous curve, so there are no holes or gaps or breaks, and there are no sharp corners or edges. The absolute value, that term with the absolute value of x is going to create a sharp corner or edge within our graph. So it's not a polynomial function because of the presence of the absolute value of x. Okay. Okay, so we need to kind of rewrite this. If we said x squared divided by x cubed, it's gonna finish with x to the -1, and the other one is gonna be 7x to the -3. But in either case, we can't have a negative exponent for it to be a polynomial, so this is not a polynomial. Okay. Okay, so you have this cube root of x squared, which is the same as x to the power of 2/3. Our powers have to be non-negative integer exponents. All right. So this, we got multiple choices here. It's not a polynomial because there's no, it's not that one. The function is not a polynomial function because it's not B. because the presence of is not C, it should be D. Because of it's not a polynomial because of that cube root of x squared. Okay. I think, again, we said for it to be a polynomial, the graph of a polynomial, there can be no holes or gaps or breaks. This one is chock full of gaps and breaks and things of that nature. So is this the graph of a polynomial? We're going to say no. Same thing here. Is this the graph of a polynomial? No. It's not A. Yeah, B says that is not a polynomial because the graph is not continuous, right? So that does fail one of our conditions for it to be the graph of a polynomial. And the thing C and D don't make any sense, right? So it should be B. Okay. Match the polynomial with the graph. Now, first it asks for the y-intercept. In order to find the y-intercept, we set x to 0. If we set x to 0, the output is going to be -3. Okay. And then if we use the leading term test, I guess this is fine. If we use the leading term test, the leading term is going to be that -x to the power of 8. So that means the leading coefficient is negative, which means our graph falls to the right. So it's either B or it's C. But because the degree of the polynomial is 8, which is even, that means the other side does the exact same thing. So it has to be B. That's the only one that falls to the right and falls to the left. Leading term test again, the leading coefficient, which is a 1, is positive. So that means our graph goes up to the right. So it can't be B and it can't be C. Let me zoom out some here. So it can't be B and it can't be C. I guess that's fine. So it needs to rise to the right. And because the degree of the polynomial is even, the other side needs to do the exact same. So it can still be either A or D. We have a y-intercept of 7, right? So the y-intercept is 7. So it can't be A, and so it should be D. We pretty much did a process of elimination. Okay. Okay, the y-intercept, if we set x to 0, the output is going to be 8. Okay. Let's see. Okay, so if we use the leading term test, right? The leading coefficient is 1, which is positive, so that means it should go up to the right. So it can't be C and it can't be D. The degree of the polynomial is 3, which is odd. That means the other side does the opposite. So we need something that goes up to the right, down to the left, and there's only one choice that does that. Okay. So we're asked to list the zeros here. Let me see the time. We still got. I'll check Zoom at the 15-minute mark. So first we're asked to list out the zeros. So we're fortunate in that our polynomial is already in factored form, so we don't have to factor it ourselves. It's already factored. So then it's easy to see the zeros. You can just look at it and see that the zeros are 4 and -8. Okay. And then what's the multiplicity of 4? So with the 4 comes from the x minus 4. There's an implied power of 1 on the exponent for that binomial factor. So then then that means since the power is 1, that means the multiplicity is 1. In other words, that 0 occurs once. But then for the multiplicity of -8, its power is 2. So then the multiplicity there is 2. Okay. So then what this tells us is that with the x-intercept of 4 having an odd multiplicity, that means the graph is going to cross the x-axis when x is 4. For that, basically for that 0, right? And then the graph is going to bounce off the x-axis when x is -8 because it has the even multiplicity. So it's going to touch the x-axis and turn around. Okay. All right, let me see the time. We got a solid 5 minutes, and I'll check attendance again for the people coming late. For this polynomial function, find the zeros, right? Again, fortunately, it's already factored, so we can just look at it and write the zeros, 3 and -5. Okay. the multiplicity of 3, right? The power when x is 3 is 3, so that multiplicity is 3 because it's to the power of 3. The multiplicity of -5 is 2 because the power is 2. Okay. So when x is 3, because it has an odd multiplicity, that means it's going to cross the x-axis. And then because -5 has an even multiplicity, it's going to bounce off the x-axis. Okay. So the minimum number of turning points is going to be n minus 1, right? So if we were to expand this polynomial all the way out, at some point you would have an x cubed term times an x squared term. So x cubed times x squared is going to give us x to the power of 5. So the highest degree on any variable here is going to be x to the power of 5. So that means we have at most 4 turning points. Okay, we give it like 3 more minutes. Okay, so for this one, it's already factored. We need the zeros from that polynomial. So we have 2 things multiplied to give us 0. The first 0 is simple, right? It's just 0. But then for the second 0, if you set that to 0 and solve, I feel like the simplest way to go about solving that one is the quadratic formula. Okay. If we use the quadratic formula, it's going to be -b. Let me see. So that's going to be a 1 plus or minus. I'm just going to put it as minus right now, the square root. The square. So b squared is a 1 minus 4. So I'm going to put my 4 times my a, which is 1, times my c, which is a -4. So then those together give us a positive 16. So that's really 17, right? All over 2a is 2. Okay. So that's one of our zeros. Okay, so now we're ready to list out our zeros. So the first 0 from x to the power of 4 is just going to be 0. And then you basically have the same result, but then plus or minus. So we did the minus already. Minus. So then it's going to be 1 plus the square root of 17 over 2. Okay. So these 3 results. Okay. So the leftmost 0 is the 1 minus the root 17. That occurs once. So its multiplicity is 1. The middle 0 being the origin has a multiplicity of 4. So that multiplicity is 4. And then the rightmost one is 1 again, because those zeros occur once. So then if it has an odd multiplicity, so that first one has an odd one, that means it's going to cross the x-axis. The middle 0, because it has an even multiplicity, is going to bounce or touch the x-axis and turn around. And then the rightmost 0 has an odd multiplicity, so that means it's going to cross the x-axis. Okay. Let me do like one more question, then I'll check attendance. All right, so this one is a little bit of a doozy, so let me check attendance first before I do this one. Cool. Wait. That's fine. 1, 2, 3. All right. All right. So let's keep going. All right. So the intermediate value theorem, when we introduced this on Monday, basically we were taking advantage of the fact that the graph of a polynomial is smooth and continuous, meaning there are no holes or gaps or breaks. So if we're looking at the graph of this polynomial and we want to evaluate it between x equals 3 and x equals 4, because the graph is a smooth continuous curve, as long as one of these endpoints is positive and the other one is negative, that means in order for our graph to go from positive to negative, it has to cross the x-axis somewhere between these points, right? So what we're going to do today is an extension of that property. You know, you can easily pass these through, you know, when x is 3, pass it through the polynomial. When x is 4, pass it through, and it should be opposite signs. So now we're trying to get a sense of how do we narrow down that 0, right? So what we're going to do, there's two techniques that I really want to show. I'm going to show a quick technique first. So the quick technique, if I go to my y equals and put in my polynomial, I have x to the power of 4 minus 3x cubed minus 12, okay? So then I'm just going to go to the graph, and again, it should cross between 3 and 4. 1, 2, 1, 2, 3, right? So it does cross between 3 and 4. So the quick way, if I'm on a TI 83 plus, I'm going to go to calculate or second trace, and I'm going to hit number 2 for 0. And then I want to move the cursor left of my 0. I'm just kind of going to the right. So there it is. So I'm going to choose something to the left of 0. Let's choose here. And then choose something to the right of 0. We can choose here. And then we want to, the third one is you try to get as close to 0 as you can. Okay. So the quick way, and it says round to 2 decimal places, gave us 3.26. That 6 tells us to round up. So 3.33, right? Now, before I submit that, suppose you don't have a graphing calculator, but I know that you have access to Excel, and Excel does spreadsheets and formulas and things. So there is a quick way to do this in Excel. It's basically looking at a table. So if my 0 is between 3 and 4, I want my table to start at 3, and I want it to change by 0.1. So now we're going to look at like we're going to look at 3, 3.1, 3.2, all the way until we get to 4, and we should notice a sign change. Okay. So I'm gonna go look at the table, which is here. We're starting at 3, we're changing by 0.1, and we're looking at the results on the right, and we get a sign change between 3.3 and 3.4, okay? So then what we wanna do, now we wanna zoom in, and to do that, we go back to our table set. So I'm gonna hit second window. I wanted to start at 3.3, and now I wanted to change by 0.01, right? So somewhere between 3.3 and 3.4, we should get a sign change. So now if I go back to the table, okay, we're looking for our sign changes, and it happens between 3.2 and 3.3. Sorry, 3.32 and 3.33, right? So because we're asked to round to 2 decimal places, we need to do this one more time. So let's have the table start at 3.32. And then now instead of changing by 0.01, now we're changing by 0.001. So 0.001, right? And so we're zooming in even further. Okay, this is the last time I have to do this. So let's go to the table. And then now we're looking for a sign change again. And the sign changes right there, between 3.26 and 3.27, right? So we know the 0 is somewhere between there, but because we only want 2 decimal places, then the 6 tells us to round up to 3. The 7 also tells us to round up to 3. In either case, they both round up. So then we still get our 3.33, okay? We're gonna check that result, and let me check on you guys in Zoom, okay? All right, cool. I can work with that. All right, so let's keep going. Let's see. This is kind of a repeat, so let's do it again. All right, let's go to our y equals. We're going to clear it out because we got a different polynomial, and I can do the following. Let's see, x hat 5. Okay, x to the power 5 minus 3x squared. Let me see. Where is it? It's not that one. Squared. There it is. Nope, it's hat. hand. So -1 log. That's 2. Store program. Sorry, I'm just trying to find a keyboard shortcut for what I'm looking for. That's applications. Log. That's clear. Okay, that's good to know. It's not any of those. It's not that. It's a shift. Okay, there's an A. What are we looking for? Nope. Sorry, I'm just looking for squared. Nope. Delete. Okay, that's good to know. Sorry, I'm coming, guys. Fractions, that's what math, okay. No, there was something here. That's 8, 7. There it is. All right, okay, found it. Clear was this one. There we go. Okay. All right, cool. Sorry, I had to trying to find a keyboard shortcut instead of having to click on the screen the whole time. Okay, so let's type this guy in. So we got, let me see, x hat 5, okay, minus 3x squared was I, okay, minus 15. Cool. Okay, cool. I don't know what the home button is. Second was like, I'm not gonna worry about that right now. Okay. So if we're doing the same thing, we're gonna go to the table set. We want the table to start at 1, and we want it to change by 0.1. Okay. Okay, let's go back to the table. Now we're looking for a sign change. It should be a sign change somewhere between 1 and 2. Okay. We're just looking for it to go from negative to positive or vice versa. All right, so between 1.9 and 1.2, that's where we got our sign change. Okay, so now we want the table to start at 1.9. And now instead of changing by 0.1, we wanted to change by 0.01. Okay, let's go back to the table. And there is a sign change there. The sign change is between 1.91 and 1.92. So now, if we're just redoing what we did before, we want the table to start at 1.91, and now we wanted to change by 0.001. Okay. If I go back to the table, this is the last time we have to do it. Looking for one more sign change. Okay. Right there. So we get a sign change between 1.919 and 1.92, right? So I think in either case, if we round these to 2 decimal places, they both round to 1.92. So 2 decimal places, 1.92. It's approximately 1.92. All right. Next question. For this function, answer the following. Describe the end behavior of f. Okay. So we use the leading term test. The leading term in this case is that x to the power of 5. The leading coefficient is positive. That means our graph goes up to the right. The degree of the polynomial is odd. So that means the other side does the opposite. So it should fall to the left and rise to the right. Falls to the left. Falls to the left and rise to the right is D. Okay. Okay. Sketch the graph. We said falls to the left and rises to the right. Is there only one that does it? There's only one. It looks like there's only one that falls to the left and rises to the right. So I'm just going to go with B. Okay. Let me check on you guys in Zoom. Cool. All right, this is what I anticipate. Next question. Was that it? Oh, we're almost done. How do we get to the next question? Okay. For this function, the end behavior, right? Okay. So you might be tempted to say that the leading term is 3x squared, but you gotta expand this guy. So it's really the leading term is negative 3x cubed. Okay. Because the leading coefficient is negative, that means it should fall to the right. Because it's really x cubed, that means the other side does the opposite. So it should rise to the left and falls to the right. Rise to the left and falls to the right. The only one that does that is D. Oh, this graph sketching is like a little bit irritating. Okay. So we're fortunate that our original function is already factored, so we can identify our zeros fairly easily. I'm going to go ahead and open up the graphing utility. Now, I was working this one earlier with the other students. Initially, it gave me a hard time, but we worked it a couple of times. We were able to kind of get it working a little bit. Okay. So let's see. So now we need to choose 4 points that are our zeros. We know that when x is 0, so the origin is one of them. Okay, maybe if I zoom in, that's fine. So what I ended up having to do on one of them was just, I clicked on 3 spots randomly, and then I went back and moved them at the end, right? So one of our zeros is the origin. So I'm gonna just slide 1 point to the origin. Let's try this again. Okay, 1 point is the origin. Okay, that's one of our zeros. We see that when x is, and it should also bounce off the origin, but we'll come back to that. When x is -2, that's another one of our zeros. So another 0 is x equals -2. So those are the, right? So those are our two x-intercepts. So what we've chosen 0. Let's do when x is -1, right? So when x is -1, that's one we get -3. So another point is -1, -3. Okay, right there. Oh, yeah, we got it. And we need one more point. Let's choose when x is 1. When x is 1, y is -9. So we have a point 1, -9. Boom, like that. So basically, we just chose 4 points on the graph. 2 of the points came from the intercepts. And then we just found two additional points. I'm gonna hit save and I'm gonna check. Okay. That was an adventure. We're almost there. We got maybe 3 more questions. 18, 19, and 20. Sketch this graph. Okay, the left behavior. Okay. So with this graph again, with something like this, you want to expand it out. Don't be fooled. You know, these are all multiplied. So this is in factored form. We want to expand it out. If we expand it, the leading term is going to be x to the power of 4. So if the leading term is x to the power of 4, the leading coefficient is 1, which is positive. So it should go up to the right. And if the degree is 4, which is even, that means the other side does the exact same thing. So it should rise to the left and to the right. And the right-hand behavior ends up, right? It should, so basically it should rise to the left and rise to the right. Okay, I'm gonna go with that. The y-intercept, if we set x to 0, it looks like the output is 0. Okay. Y-intercept oftentimes is easier than the x-intercept in that, you know, you just set x to 0 and a lot of terms just cancel away. The zeros, and we're fortunate with this example in that it's already in factored form, right? So the zeros are 0, comma, -3, comma, 4. Okay, again, if anything isn't clear, feel free to unmute yourself. We can talk about it. The multiplicity of the 0 located farthest on the left, okay? So that -3 has a multiplicity of 1. Okay. So the middle 0, which is 0, has a multiplicity of 2. Okay. And the farthest right one, which is when x is 4, has a multiplicity of 1. Okay. So that means the graph is going to cross, bounce, cross. Evaluate a test point. What's the value of y when x is 2? So that's going to be 4 times 5 is 20 times -2, -40. Okay. Okay. So we said it rises to the left and the right, so it can't be A. There's only one graph that rises to the left and the right, which is B. Notice that it cross, bounce, cross the x-axis. It does everything that, has the proper intercepts, so we're going to go with that. Okay. All right, this one as well. If we were to expand it out, we would have an x squared times x times x. So that means we're going to have an x to the power of 4. The leading coefficient is a +1, so it rises up to the right. The degree of the polynomial is even, so the other side does the exact same thing. So it should rise to the left and to the right. So it should be A. All right. I think that's the only one that rises to both sides. Okay. Okay, so when x is 3, it should bounce off the graph. Okay, so it can't be C or D. I think they both bounce for A and B at 3. It should cross. The other zeros are 1 and -3. So it can't be B because B has -1 as 0. So the only one that's proper is A. Okay. Was that it? Oh, okay. Are there any questions? All right. So I have one. I don't know if he's present or not. Oh, wait a minute. Okay, I was about to say. Yeah. So, but yeah, that was it. So I'm gonna go ahead and take that time. We actually made it through all the homework questions. There don't seem to be any questions. So we're gonna go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. Take care. See you next time. Same place, same time. Peace.